Hey, what is going on everyone? I'm Wicked, welcome back to my Dart from Novice to Expert complete course. In the previous video, we successfully managed to create, run and debug our first Dart project. In this tutorial, we're going to take a brief look into the components of a Dart project so that after you finish this video, you'll understand a lot more about packages, libraries, lint rules, and tests. So without further ado, let's get right into it. Beforehand though, I want to send a token of appreciation to everyone supporting me as official YouTube members, especially to Diana and Michael, aka Aza, on Discord. If you want to become a member, all you have to do is to click the join button right next to my channel and pick your desired membership. Having that said, let's continue with our tutorial. Okay, so this is where we previously left in the last tutorial. We managed to create this Dart project based on a console full template. Right now, all I need you to do is to completely focus on the project structure. I'll be extracting the components, because I know that will help you greatly understand their purpose and what goes where inside the project even better. The .dart_tool folder, .packages, pubspec.yaml and pubspec.log files are associated with Dart packages. On the other hand, the lib folder is related to libraries. The analysis_options.yaml file is related to how the static Dart analyzer scans the code by following a set of rules, a process called linting. The test folder is obviously linked to Dart testing. The bin folder is reserved for command line apps, just like ours, and Dart uses them to directly run the project. You already know this from my previous video. We also encountered the VS Code folder, and you know that it is associated with VS Code run configurations. The .gitignore, changelog.amd and readme.amd are Git source control related files, and you probably already know them if you worked with Git before. Now, as you can probably tell, the first component we're going to discuss today is Dart packages. Pay as much attention as possible because what I'm going to tell you right now will probably blow up your mind. What if I tell you that the concept of a Dart project doesn't really exist? There is no such thing as a Dart project. The terminology you should use instead is Dart package. Therefore, what we have here is not a Dart project, but rather a Dart package. I invite you to delete the project keyword from your mind, because from now on, we'll refer to our project as being a package. But what exactly is a Dart package? In big words, a Dart package is the main component of the Dart ecosystem. Everything inside the ecosystem spins around Dart packages. There is actually a place where Dart developers from the entire world gather and upload their Dart packages to. You might have heard about it, it's called the pub.dev platform. Pub.dev has an immense upgrowing collection of published Dart packages, but why exactly does this pool of packages exist in the first place and what is its purpose? Well, the main idea when having all these packages is that we, as developers, can help each other out. What do I mean by that? Well, let's say that inside our current package, we'd want to retrieve some data from an API, parse the JSON to a local instance of a specific class, and then store the content into a local and fast database. I'm completely sure that if you'd have to implement all of these features from scratch, you'd probably lose your mind. Or if you wouldn't, it will probably take you a really long period of time. So here comes the power of Dart packages. What's really amazing is that there is an already existing Dart package for every feature I've previously mentioned. You can retrieve data from an API by using the HTTP package, parse the JSON to a specific class by using the JSON serializable package, and store the content into a local and fast database by using the Hive package. Therefore, the main characteristic of a Dart package named A, for example, is that it can depend on other Dart packages named B, C, or D, but the others can also depend on package A. Of course, the latter is only available when the package A is uploaded to pub.dev. Ours obviously isn't, and it won't be since it doesn't bring any good value to the ecosystem. Therefore, we can only depend on other packages. A package that is not going to be publicly posted on pub.dev is called an application package, while a package that will be indeed posted is called a library package. So, we understood that our project is actually a package and that we can depend on other packages inside of it. Then you might say there must be a package manager that has the job of controlling everything related to our package and to the packages it depends on, right? And indeed there is. The Dart package manager is called pub, just like the website containing all packages. If we open up the Dart CLI, you'll see that there is a separate command named pub, containing a bunch of other subcommands related to package handling. We'll talk about these more in depth inside the full tutorial on Dart packages. However, you might notice that inside each package, there must be a file organizing the properties of that package, and that is including its dependencies on other packages. Indeed, its name is pubspec.yaml. Inside of this file, it is mandatory to specify the name of your package and the SDK constraints that denote on which Dart version your package actually works on. As I mentioned before, the dependencies you see here represent a list of external packages your package will depend on. Currently, our package depends on two external packages called pedantic and test. That means we can find them on pub.dev and see what they're all about. It's really convenient that the pedantic package is related to the linting topic, while the test package is related to the testing topic. Topics we'll cover up later in this tutorial, but before that, let's talk a little bit about these files. What I can tell you about them is that they have been automatically generated by pub when we ran dart pub get. But did we run that command? Well, we didn't manually run it, but whenever Dart creates a new package or whenever we save the pubspec.yaml file, it will get called automatically. Notice from the CLI that this exact command is responsible for retrieving the current package's dependencies. So what it actually did is went and downloaded the pedantic and test packages from pub.dev, and not only that, but obviously also all the packages they depend on. We can actually notice all of the imported packages by going into the package_config.json file, and man oh man, as you can see there are lots of them. The .package file is just a deprecated version of the package_config.json file, and the pubspec.log mainly links our package to the exact same versions of the packages we depend on. All in all, they mostly contain the same kind of information associated with packages. But one keynote I want you to observe before we wrap up this topic is that at the end of the package_config.json file, you can notice one interesting fact. The name of our package is also listed up there, proving what I have previously said, that our Dart project is actually a standalone Dart package. Moving on, we learned that developers incorporate inside packages different implementations and algorithms associated with often requested features. Huge and mad respect for them. But how do they expose their work from inside their own package, you might ask? The answer to that question is through libraries. The relationship between a package and a library is that a package can contain one or multiple libraries. Please pay attention to what I'm telling you right now because it's really important. Libraries are the only part of the package that is publicly accessible to everyone. So whenever you're importing a specific package, you only have access to the libraries written inside the lib folder and nothing else. If a package like ours contains a bin folder and is uploaded to pub.dev, others won't be able to import it since all they can access is the lib folder containing our implementations. These rules mostly apply for library packages, packages that will be on pub.dev and that can be dependent on. However, this doesn't mean that in an application package like ours, which won't be posted online, we're free to place every file everywhere in a haywire manner. It's still a great idea to stick to these existing implementation rules from inside the Dart ecosystem. This way not only we'll learn more about it, but will also be more organized and structured. Unfortunately, in our own package, the lib folder isn't properly structured, since this implementation should have been posted in a source subfolder within a file that should be publicly exported as a component of our library. I'll make a separate tutorial in which I'll talk more in depth about libraries and these rules, but the key fact to be understood is that we let packages communicate between one another via the implementations we write inside the lib folder. It is time to move on to the next component we'll cover up today, the Dart linting. You might remember a while ago in my first tutorial of this series when I introduced you to the static analyzer. Its job was to take a look over the code and signal any potential warning or error in real time. Now you might wonder, how is the static analyzer programmed to check for these kind of warnings and errors? The answer is by reacting on a predefined set of rules called lint rules. This process is actually called linting. We saw that by default the pedantic package was included as a dependency. This package contains the lint rules used internally at Google when developing apps. But how is this pedantic package set as a default analysis option, and how can we see the lint rules it incorporates? To answer both of these questions, we'll head over to the file that is responsible for the job, the analysis_options.yaml. This is the file the static analyzer communicates with to retrieve all its rules. You can see at the top that there's a line of code including the specific analysis_option library file from inside the pedantic package. How we can see that file though? The easiest way to browse for a specific dependency package folder is to go right down here into VS Code Explorer, click on the dependencies tab and search for your desired one. After we find the package and follow the imports path to the actual file, we can finally see the entire set of lint rules from inside the pedantic package. Most of them are self-explanatory. Take a void init to null for example. If we go back into one of our dar files, you'll see that the static analyzer won't allow us to initialize a variable to null, and if we hover over the warning, you can observe that it is actually the same exact lint rule we previously saw. Pedantic package is not the only package specialized into providing a set of lint rules for our analyzer. There are a bunch of other ones available on pub.dev, some of them stricter than others. One I can recommend you check out is the Very Good Analysis package that is actually used internally at Very Good Ventures. Again, in the future, I will make a separate tutorial on effective Dart and lint rules in which I'll explain best practices that will help you have a consistent, robust and maintainable code workflow. For now, I hope you understood how the static Dart analyzer scans the code you type. It is now time to move on to the last components of today's video. It is probably the most omitted, yet really important component of any Dart package. I'm obviously talking about tests. Tests represent one of the pillars that add a lot of value onto the development and maintenance aspects of a project. They are the pieces of code that we write in order to make sure the features and implementations we coded behave and output things as expected. Ideally, for every feature or added functionality, we should have a test checking if it is working good or not. In Dart, tests are written inside the test folder in files appending _.test at the end. In our case, we have a test verifying if the output of the calculate function is really the expected number of 42. This is called a unit test and it's the simplest test we can write. But how do we run it? As you have probably guessed by now, you can do it from inside the editor or from inside the Dart CLI. Inside the editor, we actually have a dedicated panel we can go to, called testing. At the top, we have multiple buttons to run the tests. We're interested in running them all, so we'll click the play button and wait. Our test obviously passes. Inside the CLI, you can also observe there is a test command we can run that will automatically run all tests. And again, our only test passes with 100% success rate. There are so many aspects of writing Dart unit tests, and obviously I can't cover them right now since that's not really the purpose of this video. As I've previously mentioned, many of these components I'm covering up today will have their own separate tutorials, and tests make absolutely no exception. It is finally time to wrap up this tutorial. I really hope you understood the components we discussed today. There is one more important subject we need to tackle on, and that is what happens behind the scenes when we run a Dart program and what's the difference between all the available compile methods. In the next tutorial, we'll do just that. If you like this tutorial, don't forget to smash that like button, subscribe to my channel and share the video with all your friends and colleagues in pursuit of top tier development. Until next time, as always, take care, Wicked is out, bye bye.